The value cannot go from 0 to 1. So always bear that in mind. So now, when we use this formula, so this will be the highest and this will be the lowest. So we also must know that the width of the confidence interval, correct? You look, is the highest minus the lowest. Always remember the width is the highest minus the lowest, correct? When you take highest minus the lowest, so you got double Z alpha over 2 square root of P hat 1 minus P hat over N. Yep. And you know that it cannot be more than 1 also, correct? So this is the width. So from here, if we know the width, if we want a desired width, then we should get the sample size, correct? So if you rearrange this formula, the sample size will go in this way. Yeah. So you put it up, you square everything. So what do you get? Then after that, you square root it. So what is the one? So it will be 2 times of Z alpha over 2 divide by the width, the whole thing squared, times by P. Okay, look, in this case, we don't put P hat or the textbook there, they put P x straight 1 minus P x straight. That means the P can be any value. There are 3 possible values. Okay, so now before I explain the 3 possible values, so now can I write this as, this is definitely a constant. If you fix the confidence in a level, you fix the width, so this will be a constant, correct? So your P will be the variable. Yep. So now if I plot this graph, okay, everyone take out your graphic calculator and plot this graph, and you know that the P value cannot be more than 1 and cannot be less than 0. So can you plot this graph? N against P. N's against P. So you should know this is a quadratic when you expand, correct? So when P equal to 0, N is 0. When P equal to 1, N also equal to 0. Am I right? So you got a graph go like that. And you know that this is the maximum sample size. So from here, we always conclude maximum sample size for a specific width and confidence level always happen when P equal to 0.5. So this is a true fact about sample size for proportion situation. Whatever is it. Okay, now, can I? So I explained to you already. Okay, now if you look at example 14, can I move on? In this case, you want to find sample size. Okay, so the only P that you have is population proportion. So now in this question, P0 represent population proportion. I should say all. Okay, all population proportion, correct? So now you can use that. So that's why they put the asterisk here to tell you actually there are 3 choices. All population proportion. Another one is if you have a sample proportion, you also can use. Okay. If you don't have both, then you can use 0.5. Why? Because as long as you use 0.5, that is a maximum sample size. Do you get me? So now every time when you are given a question, you have to check. Okay, now, is population proportion given? All population proportion, is it given? Yes. If it's given and I don't have a sample proportion, then I will use the population, all population proportion to help me to find the sample size, the suitable sample size. If both are not given, then I will use 0.5. Now, if the all is given and a sample proportion is also given, then which one should I use? I have to ask myself this question. Is the all population proportion outdated? If it's outdated, then I cannot use it. I have to use a sample proportion to help me to judge the minimum sample size. Do you get me? Like, for example, I say, okay, I give you in 1990, okay, proportion of people who have Facebook account is 0.1. Do you think that is outdated? Yeah, that is outdated. So I won't use that. I will use my sample proportion to find a suitable sample size. Are you clear? And your sample size is always, you must round up. And please remember, I told you already, in any formula, all the percentage have to change it to decimal. Clear? Student, take note. If I give you width is equal to 2 times the margin of error. And width also 2 times of whatever stated in within. Can or not? So please remember this.